All right, so we're going to take a look at the 2.3 homework, the word problems. Again, if this video doesn't help with anything or you still have questions after looking at it, make sure to ask questions in class. There's always slight variations in the way that people might set up their problems. So if that's something that happened, you want to see if that's okay, bring it up in class. All right, so for number one, it's about buying season tickets. There's 80 basketball games and tickets are $9 each, or someone could buy a season ticket for $580. So I've let G represent the number of games attended, knowing that 9 times G would be how much I spend on each game, and then multiply by G to find out how much it costs for the total games attended, is less than or equal to the $580. So we're trying to figure out, is it better not to buy the season tickets or buy the season tickets? Divide by 9 and get G is less than or equal to 64.4 games. So what this means is that if I'm only going to attend 64 games, it's not worth buying season tickets. By the time I attend my 65th game, it would be better to buy the season tickets. Number 2, so it talks about paying a bridge toll. It costs 50 cents to drive across the bridge, or you can buy a special sticker for $5.50 and then only pay 35 cents to cross the bridge. And it wants to know the least number of trips are needed before the sticker costs less than paying for each trip separately. So I've let T equal my number of trips. I know that I can set up 50 cents times T to represent not buying the special pass. I'm making that greater than or equal to the 0.35T plus 550, what it would cost if I bought the special pass, and then how much it would cost to travel across the bridge. Start solving by subtracting my 0.35, T, divide by my 0.15, and I get T is greater than or equal to 36.667, or 36.6 repeating. So what that tells me is that if I'm only going to make 36 trips, buying the pass is not worth it. But once I've made that 37th trip, the pass is worth buying. So if it's going to be 37 or more trips, I would buy the pass. If it's going to be 36 or fewer trips, I would not buy the pass. Number 5 wants the sum of 3 odd and consecutive odd integers to be between 20 and 30, very similar to the examples we've done in class. So I've labeled my variables, set up my equation as we saw the equation set up. 20 is less than the sum of those variables is less than 30. Again, I've put x plus 2 and x plus 4 in parentheses to emphasize they represent a single value. That group represents either the second or third integer. Combine my like terms, start solving, divide by 3. And so I find that the first number has to be between 4.667 and 8. So the first odd number between those two values is 5, which would make my first set 5, 7, 9. There's another odd integer that fits between 4.667 and 8, and that's 7. So my second set would be 7, 9, and 11. There are no more odd integers that fit in between 4.667 and 8, and so I've got my answer. 6 is very similar, only difference is now we're talking about even integers. It doesn't change the setup. Our first value would be x, our second value would be x plus 2, our third would be x plus 4. Set up my inequality in the same way that I did in number 5. Combine like terms and start solving. Divide by 3. And I get that my values have to be between 6.3 and 13. So, first even number between 6.3 and 13 is 8, which would make my first set 8, 10, and 12. Next even integer that fits between 6.3 and 13 is 10. So I've got my third set, 10, 12, and 14. And then my third even integer that fits between 6.3 and 13 is 12. So I've got my final set, 12, 14, 16. Number 7, very similar to what we set up in class. We know that somebody's taken 4 tests. They want to know what score they need to get on their 5th test to have a grade, an average grade that is at least 80. So that means that I'm going to include the or equal to. If it had said greater than 80 or more than 80 or better than 80, I would not have included the or equal to. So I set up the sum of my tests divided by the number of tests, combine like terms, and then to get rid of this fraction, I'm going to multiply by what the denominator is. On the left-hand side, it'll cancel. On the right-hand side, I'll get 400, subtract 307, and I get that t is greater than or equal to 93. So they need a 93% or higher to get their 80%. I'm going to reread the problem real quick. So they said average of at least 80, so it is 93. If it had said greater than 80, they would actually need to get a 94. Sorry, number 8 is at the top. Now, number 8 is very similar to what we just did in number 7 with some minor changes. We don't know their first score. They told us the second score is 8 points higher, and the third score was 88. On top of that, we want to see if we can stay in the B range, which is between an 80 and an 89%. So it is almost kind of combining what we saw from number 7 with number 5 and number 6. So I set up the sum of my scores divided by the number of scores, combine like terms, start solving by subtracting 96 from both sides, divide by 2 on both sides, and end up with 72 is less than or equal to x is less than or equal to 85.5. So the first test score must have been somewhere between a 72 and an 85.5. We can't say for certain where it was, just that that's somewhere that it must have been in between. All right, and then finally number 11. Sorry, let me scroll down to it. Now, there's multiple ways to set up number 11 because of the 40-minute use in this. But basically it talks about that there's a monthly plan where you can spend $18.50 and have unlimited calls, or there's a monthly plan where you can spend $6.50 and then 10 cents for every minute after 40. Now, because of the way I define my variable as the number of minutes used, when I set up my equation, my $6.50 plus 0.1 times m minus 40, the m that I've defined is all the minutes. Some people might define their m as the minutes after 40, and that would make a slight change in their equation. From there, I distribute my 0.1, combine my like terms, and start solving. By the time I divide by 0.1, I get that m is greater than or equal to 160. So what that's telling me is that plan A is better after 160 minutes. If I'm going to make 160 minutes of calls, neither plan matters because they're going to amount to the exact same value. But by the time I make more than 160 minutes worth of calls, plan A becomes the better plan. All right, hopefully that helps. If not, definitely feel free to ask questions in class. See you soon.